In the 1960s, a Norwegian doctor called Lawrence Gran was working as part of a Red Cross relief effort in what was then known as the Republic of Congo.
He noticed that when women went into labour, that the labour would be very fast. And what was actually happening is that they were making a tea from a local plant called Kalata, ingesting that tea, and it would accelerate the childbirth process.
The active ingredient was a molecule, or peptide, that Gran named Kalata B1.
But at the time he couldn't determine the structure of this molecule, and it was really 20 years later that I came along and found that the structure had this very interesting head-to-tail cyclic structure that made it super stable, and that explained to us why this molecule could withstand the boiling and then the oral ingestion.
By working that out, Professor David Craik became the first scientist to document circular peptides of this size.
Most peptides, like insulin, couldn't be boiled or couldn't be orally ingested, but this molecule could be, so it led us to this whole new area of super stable molecules.
And a whole new world of possibility. He called these circular peptides cyclotides. Today, thousands have been discovered in plants around the world. Much of that work has been done here at Professor Craik's laboratory at the University of Queensland.
We know that plants make these molecules very effectively. What if we could re-engineer a plant to make a medicine so that, in principle, you could grow medicines in your backyard?
His goal is to cut the costs associated with pharmaceutical development and dramatically increase access to medicine, particularly in developing countries. One example his team is working on right now is to integrate a multiple sclerosis drug into tomatoes,
so that people with chronic multiple sclerosis could maybe have their Greek salad and have some level of medical protection from the disease in their everyday diet. So there's lots of exciting possibilities for turning foods into medicines.
Professor Craik believes there's a big opportunity for Australian farmers to set up biofactories for innovative peptide-based drug production.
Rather than growing a crop that might be worth $100 a tonne, it could be worth $100,000 a tonne by producing a high-value medicine in those plants.
These peptides also have applications in agriculture. One Australian company, for instance, has already developed an insecticide from butterfly pea plants containing cyclotides, which is now being used to protect crops such as cotton. The product is non-toxic, making it safe for pollinators such as bees. Professor Craik says this is just one example of how his circular peptides can be utilised.
We've been working in this field now for 20 years, and when we started there was nothing known. In fact, people used to say this can't be true, you can't have cyclic peptides of the size that we discovered, they just had not been seen before. And then we went on travelling around the world looking at many different plants to find out just how common these molecules were. Really it's come a long way from the initial stages where this was a little hobby project 20 years ago, but it's basically become a passion and an adventure for the last 20 years or so.
An adventure that's now been recognised with the prestigious David Craik Medal from the Australian Academy of Science.